Hi, my name is Muhammad Shaful bin Ghaffar.
Hi, my name is Kashini Kumar.
Hello, I'm Ashley Kwaliting with student ID 17009090.
Hi, my name is Tani Shan.
Hello, my name is Levi Jin.
Phosphate fertilizer has become high demand in agriculture industry as it helps in strengthening the plant's stem and roots. There are two types of it that commonly being used, which are monoammonium phosphate MAP and diammonium phosphate DAP. These products can be obtained through neutralization reaction process between the phosphoric acid and ammonia. However, this reaction produces waste phosphogypsum PG that can harm the environment as it high in acidity or basicity if it not been treated properly.
These are the problem statements and objectives of the project. The problem statement are the downside of the phosphogypsum waste produced of the manufacturing of phosphate fertilizer and the selection of the suitable controller used in the pH control system. The objectives of the project are to discuss the pH control system used in the production of phosphate fertilizer. Secondly, to discuss the challenging concern of the process control of phosphate fertilizer. And lastly, to discuss the steps taken to reduce the waste produced of the production of phosphate fertilizer.
I'm Ashley and I'll be presenting on the critical analysis on how the control system works. The control system used in the treatment of phosphogypsum waste of the phosphate fertilizer manufacturing industry is pH control system operating as a feedback control loop. The untreated influent of phosphogypsum waste from the wet acid process required in the manufacturing of phosphate fertilizers to produce phosphoric acid first enters the agitation tank, where a glass pH electrode, which is the transducer, will measure the pH value of the slurry holdup in the tank and compares it with the desired set point of neutral pH value set by the PI controller, that is at a value of 7.0 to 7.7. An error detected, which is pH value that shows acidic properties which is less than 7, will then signal the on-off controller to control the actuators, that is the base region pump or neutralizing region pump, to be fully open or fully closed based on the error situation, where the main objective is to neutralize the acidic phosphogypsum waste in the tank. The base region pump will be fully open if the error is present, that is the holdup in the tank is acidic, whereas if the slurry holdup is within the desired set point, the on-off controller will fully close the base region pump and determine the holdup in the tank in order to either fully close both region pumps or allow the neutralizing region to be added. This is so that overflow of the tank can be prevented. After the pH of slurry holdup in the tank is determined to be error-free and within the desired set point, the phosphogypsum exits as treated and neutralized effluent to be reprocessed in the main fertilizer plant or utilized in the cement industry.
Moving on to challenging concern of pH control system. The first challenging concern is temperature variety in waste phosphogypsum stream due to the change of operating temperature between sulfuric acid and phosphate rod in phosphate fertilizer production. If the operating temperature increases, the temperature of waste phosphogypsum stream will also increase, causing more residual acid in this stream to ionize and form more hydrogen ions. This situation will cause pH control system to neutralize the waste phosphogypsum stream to desired pH set point based on incorrect temperature slot. The second challenging concern will be relay hunting around pH set point. This situation happens when the waste phosphogypsum stream has reached desired pH set point. The caustic dosing pump will stop pumping caustic solution into it. However, the mixing pump was still operating, which caused the pH level of the phosphogypsum stream to drop again. It will start the caustic dosing pump again to neutralize phosphogypsum stream back to pH set point all over again, and so on. Next, the third challenging concern will be pH measurement in liquids with hydrofluoric acid. The waste phosphogypsum stream contains residual hydrofluoric acid, and this acid has high reactivity towards glass and the ability in dissolving glass. This characteristic will dissolve the glass electrode in pH control system and cause the pH measurement to be inaccurate.
Now, I would like to give some recommendation for the improvement of the problem that stated by Ishan. For the first challenging concern, the proposed solution is to install a temperature sensor in the pH meter, since the temperature varies in waste PG produced during the reaction between the sulfuric acid. The sensor measures the pH based on the temperature character slope. Next up, one of the simplest ways to solve the second concern is to allow the pump to continue the dose even after the set point, which is pH 7. This will prevent the dose pump from hunting and will not lead to the breakdown of the expensive dosing pump. Apart from that, Keeping the pH high is one of the solutions that can solve the third challenging concern. This method will extend the life of the pH measurement electrode. This is because nearly all of the fluoride ion is present as non-corrosive free fluoride when the pH is high enough. In addition, utilizing a material that is not affected by the hydrofluoric acid, which is antimony electrodes, is another solution to solve the third challenging concern. This method is good and cost-effective.
To conclude this project, it is aimed to study a zero waste management approach for one of the chosen chemical industry in Malaysia using a suitable process control system to achieve a zero waste goal. The fertilizer industry is chosen as it is one of the most important industry as it ensures a sufficient food production provided by a plant from getting nutrients from a high quality fertilizer to provide a healthier growth. The phosphorus fertilizer is chosen as it is one of the most common fertilizers used these days. To conclude, the control system used for the production of phosphate fertilizer is a pH control system. Although there are a lot of challenging concerns in the usage of pH control system in the production of phosphate fertilizers, there are few steps taken to reduce the waste produced on the production of phosphate fertilizer as well. Thank you.